It's important to talk about museums and how to interpret fossils that are there and any literature you may find there. In this particular place, this is a great museum to visit, and I got to take a moment to acknowledge that the amount of work, effort, and expertise putting in these exhibits is extraordinary. It is important that you understand at any museum you visit that there's only so much space. So museum pieces have to be usually consolidated and put into a smaller area, which means that you may not have consecutive fossils from specific time frames all in the same area. So as we journey through our time at this museum, I want you to keep that in mind in any future museum that you visit. But the credit for the work that they've done here must be acknowledged. So let's get started. Hi. We're at the Black Hills Institute of Geologic Research in South Dakota, specifically in Hill City. So there's so much in this museum that's worthy to talk about. You just saw a plesiosaur, and that was a marine reptile during the Mesozoic. But marine reptiles weren't all that lived during that time, as we know. So we're going to walk you through a number of different fossils to show you what's going on here. When you look at this plesiosaur, you can see that it's a predator. You can see by the teeth, the serration on the teeth. And you might notice that this specimen is articulated. That means that all the bones are together. Fossils that have been found, but you can take a really good look at the strength of that jaw. As we continue on, I want you to notice that at the same time plesiosaurs lived, we started having other critters as well. Even mosasaurs, which you see right here, which were probably the most ferocious of all marine reptiles during the Mesozoic. And you can kind of see why. They were very large, some not as large as others, but important to recognize that not just on land, but in the oceans, and I might add lakes and rivers, we had predators, we had other types of species who would have been their prey. So as we continue our journey, let's start looking at some of the other critters that existed during this time. On land, we have Stegosaurus right here. Stegosaurus has a really small brain in comparison to the size of its body. But a very important thing are these plates. I was lucky enough to get the chance to prep one of these plates, not this specimen obviously, but at a museum in conjunction with the dinosaur dig that I did. That was legal, I might add. When you start to see Stegosaur, you might wonder, okay, well, why is he next door to something like Tyrannosaurus rex? And as you start looking at these various different fossils, this museum has them together. That's important to note because you have to understand the geologic record and the sequencing of when things lived to kind of interpret what you're seeing in a museum. All right, so not just did we have predatory animals and animals they fed on, we have a fossil record that is full of plants on land, such as these cycads right here. Cycads may have been some of the more primitive plants on Earth, but they've also been some of the most durable. They have survived most all the mass extinctions. In fact, we still have them today. Flowering plants did not appear until the early Cretaceous period. And you start to see that, you're like, wow, okay, what were they? Well, they were like pine trees or things similar to that. And these types of organisms became very prolific at different times of the geologic past because they needed water to germinate. They had to be close to a water source. And then ultimately, plants diverged or they evolved, and they began to be able to germinate outside the presence of water. Another example of a fossil that's a plant would be that fossil palm tree you see there. That is actually a form of carbonation for fossil preservation. And not all plants are petrified. Not all of them are carbonized. You can see, but most of them between those two are. Sometimes we get lucky and some are stuck in amber or some other method of preservation that is non-altered, but very rarely. So in addition to plants, if you look up and see a pterosaur and a number of predatory dinosaurs up there, and I might add there's a couple that aren't, but the pterosaur was a flying reptile. It's not a dinosaur, it's a flying reptile. So the age of the dinosaurs really was the age of the reptiles. Doesn't mean that mammals didn't live back then, it just meant that reptiles were the dominant species of that time. So we're going to take a look at some different aspects of what's going on throughout geologic past, and I'll take the time to explain some of the features that you're seeing. So let's focus in on phytosaurs right here. These were freshwater reptiles, so you might have found them in swamps, lacustrine, like lake environments, and maybe even some rivers. But watch out, because they are dangerous dudes. Of course, they're extinct now. We think of crocodiles, and they were much like that. But they had some very ferocious bites, and they lived at a very specific point in geologic time, which was the late Triassic. So we sometimes can use these fossils to help us narrow the range of geologic age based on what geologists know and paleontologists regarding the age dating of rock layers if we find these fossils in them. In addition to reptiles, we also have amphibians. Amphibians, some of them were just as mean as some of our phytosaurs and even some of our land animals that were just ferocious at different points in geologic time. And here's an example of that right there. And this is just one of those animals you would never have wanted to come in contact with when he lived. So these animals have come and gone throughout geologic history based on the niches or niche that they filled in their ecosystem. So mixed in with things like phytosaurs, our dinosaurs, our plesiosaurs, our mosasaurs, we also have ice age animals such as mammoths. If you'll take a look at the mammoth skull that you see, this mammoth skull is a good example of a Pleistocene age fossil. You even see a pygmy mammoth right here, in addition to a pygmy mammoth fossil. These actually are found off the coast of California. If you look towards the back, you'll see a replica of a mammoth, a baby mammoth that's woolly, and it's been bronzed. And then you can actually see a limb bone of an actual mammoth to give you perspective of the giant size. There are multiple species of mammoths. In Texas, we have Columbian mammoths, but this far north, they had both Columbian, they had woolly mammoths, they might have even had a few Jefferson mammoths. The point is not all of these animals lived at the same time. Right next to our mammoths, we have this large ostrich-looking bird right here. This did not live at the same time as dinosaurs. It lived later on in geologic feature. So when you're in a museum like this, you need to be realizing that just because exhibits are next to each other, that doesn't mean that they represent the same geologic time frame. And you can see that well with the ostrich-type fossil right next to the mosasaur in its background. So we're going to move on and look at some of the other important things of the fossil record. So as you're looking at these specimens, one of the things I want to point out is how can you tell a predator from a prey? And I think by now most of you know that answer, but we're going to show you some specifics. So we're going to start with some of the models and skulls that are up here. You're going to see a number of predatory dinosaurs from Tyrannosaurus rex. Most of these are T-Rex fossils right here. But you're also going to see some others. And some things you should notice besides the serrated teeth, they have big orbital or eye sockets. That's a real important aspect of Saurikian dinosaurs. There's basically two lineages of Saurikian dinosaurs. There are theropods and then there are sauropods. So all of your predators fall in the theropod category. So all of them were Saurikian dinosaurs. And in addition to their serrated teeth and their big eye sockets, they would need good vision and good olfactory smell potential to recognize and and be able to sense their prey. They have a very unique hip structure. So that's what makes them Saurikian dinosaurs, that they could put weight on how they would operate their legs. So like I said, there's two lineages of Saurikian dinosaurs, but your theropods were two-legged dinosaurs that had to run in most cases. So they have a very specific hip joint that makes them allowable to do that. Then you start looking at their toes and their feet. They resemble what we see as a modern day chicken. There's a relationship there. And they have an ability to have a flexible ankle which allowed them to run, where their other lineage of Saurikian dinosaurs did not have that. They were more flat-footed. So as we kind of turn the corner here, you're going to notice some more other skulls that were predators, and then the pterosaur again. But right below them, notice the teeth on the black case, or the white case that you see some black skulls right above it. Camarasaurus. Notice how the teeth are different. See that they're more lapped. They were designed for chewing. They were designed for grinding down things that were plant-like matter. As we shift away from dinosaurs for a minute, let's look at some important fossils. This one's a placoderm on the right with very sharp jaws, and that's exactly what he had. As we venture on to look at some other species, these are various types of cephalopods. Some are ammonites, some are different types of cephalopods, and then you get into some bony fish. The point is the exhibits aren't just one thing. Museums have to maximize their space. And also museums have to get specimens donated. Some they may purchase. So they have to give credit to each and every find that they have. So while we're talking about finding fossils, let's discuss the realities of fossil collection. So vertebrate fossils are protected by PRPA, Paleontological Resource Preservation Act. And you must have permission on public lands to get them. By the way, these are models of cephalopods, some coiling, some non-coiling, and then you have some actual vertebrate bones. But since we're talking vertebrates here, if you found these bones in nature on public lands, you would need a permit from the government to collect them. On private land, if it's yours, you own them. If it's someone else's private land, you need to have an agreement in writing. This is a very special fossil known as a Eurypterid. It's a sea scorpion, of which were some very scary animals during the Paleozoic era. Some got larger than human size. Then you see some enormous gastropods, and then I see what looks to be like a turtle, a variety of fossils. But these fossils just don't automatically come and appear. So museums spend quite a bit of time finding partners that they can use specimens or get the donations to put them on display. One of the real challenges of a museum is to make sure that they have someone that is versed in all of the content and understands how these things are preserved, what they are. For example, we're looking past this vertebrate fossil there, you'll see teeth, and some of these are teeth of mammoths, the ones that look like shoeboxes, and as we move below them, we'll see what are called stromatolites. Stromatolites are fossils that, actually they live today, they're referred to as living fossils, but they also represent some of the Earth's original climate changers that gave us oxygen. Here's a smilodon or a saber-toothed cat, some more stromatolites to the left. And every fossil in its own right has a story to tell. That's what makes these museums that house any kind of natural history so important for people to get out and see. These are echinoderms. They all have five-fold symmetry. Echinoderms can be crinoids, blastoids, sea urchins, sea cucumbers, starfish. But in some cases, and especially in North America during the Mississippian period, some rocks are so heavily cluttered with this material that it spells its own story simply because
these fossils were fairly widespread for a short period of time in terms of concentration here in the United States during that time frame, but not elsewhere in the world. Then we'll shift our gears and take a look at some more of our cephalopods. And this museum did a really fabulous job of giving some history about the local areas where these fossils were found. And each and every one, while some are very similar, they have different specimens, so many. I was very impressed with the variety of specimens and quality of specimens that this particular museum had on display. And again, each and every one is tagged properly. So you can learn a lot by going to visit a museum, but you have to be willing to read all the material and then take the time to absorb what it means. Like this is the trilobite section. Well, trilobites are just one type of arthropod, but there are thousands and thousands of species of trilobites. And since they are such a big deal in geology, paleontology, they do merit their own section of a museum, and oftentimes you will see a section dedicated to these particular organisms because of what they represent in terms of the change of fossil record. While we started seeing fossils that were not just soft-bodied. As we shift gears towards the end of this virtual field trip, every single fossil matters. Every plant fossil, every vertebrate fossil, every dinosaur, every sea urchin, every trilobite. Fossils are just extraordinary. We don't get to make any of these animals that are extinct anymore. So as you look at this one, this is Sue, or a replica of Sue, very famous dinosaur in its own right for being one of the more complete T-Rex fossils. I would also point out that these are articulated fossils, meaning the bones are together, and in hopes that they were found that way in the ground. That's why it's so important that people not disturb fossil finds on public lands and allow experts to come in that can do the research to give the scientific value. Museums just help put that on display to educate people. So let me encourage you to get to a museum like this and enjoy it. We want to provide our gratitude to the Black Hills Institute of Geologic Research and its museum for the site exits to their exhibits for educational video use. More to come. We'll see you at the next stop. Bye.